You are looking at the Toronto International Airport. Typical of the best of big city airports, it is a modern air transportation system incapable of handling the increasing demands of moving more people and things faster. Last year, scheduled air carriers flew passengers and freight 255 billion miles, depositing hundreds of thousands of tons of pollution into the atmosphere. The big question is, what form of energy-generating system will replace the internal combustion jet turbine engine? You are looking at part of the Metropolitan Toronto Thruway system. Typical of the best of big city thruway systems, current growth rates show that it is incapable of handling increasing demands of moving more people and things faster. These internal combustion engines are burning gasoline. Internal combustion systems are approximately 16% efficient, measured at the wheels. The result? Some 4/5 of every gallon of gasoline purchased becomes pollution. Each year, we manufacture cars and trucks in increasing numbers. These cars and trucks partially burn critically limited resources. Various studies agree that this cannot be permitted to continue. The question is, what will replace the internal combustion engine? This is a steel-producing factory. Typical of most modern heavy industrial systems, the furnace engines are burning coal. The best energy conversion system using steam is only 39% efficient. All the rest becomes pollution. Pollution in the long run threatens the lives of every living thing. The big question is, can we develop a cheap, non-polluting method of generating ample electrical energy to operate a given production capacity to light, heat, and air condition the premises, to recycle the solid and liquid waste, and purify the water and air? You are looking at a typical hydroelectric grid system. Here, large high-voltage electrical flows received from the generating site are broken down into smaller, more manageable amounts for industrial, commercial, and private subsystems. To carry an electrical current from its point of origin at the generation site to the point of ultimate use involves tremendous electrical losses. The greatest electrical demands come from densely populated industrial areas where electricity is needed most to operate essential services such as light, heat, air conditioners, and elevators. Excessive demands have already caused brownouts on the northeastern seaboard. Blackouts may not be far behind. The big question is, what electrical generating system can replace existing generating facilities and deliver abundant electrical energy where it is needed cheaply? You are looking at a thermonuclear reactor facility. The reactors run on fissionable radioactive fuel. The heat generated as a byproduct of the reaction is used to convert water into steam. This steam is in turn harnessed to push a turbine generator, which then generates electricity. Systems like these using steam to generate electricity are approximately 31% efficient. There is a constant flow of fresh water drawn into this nuclear system from Lake Ontario, which is used as a coolant. In these waters, the warm summer season arrives 3 weeks earlier in the spring and stays 3 weeks later in the autumn. This temperature increase is called thermal pollution. The big question is, can mankind cope and develop better electrical generating systems to replace the dangerous atomic ones? capable of delivering vast electrical outputs safely and cheaply. The film segments we've just seen provide inescapable evidence that the modern industrialized societies are in the midst of the first global technological crises involving our survival. This crisis combines elements of a global energy crisis and a global pollution crisis. As we increase our development of energy to meet an increasing demand, we consume limited natural resources. The byproduct has been heavy global pollution. This program deals with energetics and a special case technological breakthrough which circumvents the second law of thermodynamics and will eventually make electrical energy freely available. Adaptation of this breakthrough promises a first generation of energy regain machines, each a self-contained closed system which, once activated, run indefinitely and consume no fuel. Each of these energy regain machines have been created, designed, and built in Canada by a team of Canadian scientists and engineers. The president of Energetics and director of the research team which created these new machines is Mr. Ian Taws. He directed the research team in Canada which developed solid fuels used in the Polaris missile system, America's frontline strategic defense system. For years, the president of Designex Limited, one of the largest engineering think tank firms in Canada, he supplied the chief technical advisor to the chief of defense staff in Ottawa, as well as providing engineering problem-solving services to the aircraft industry, the automobile industry, and the oil industry extensively. During the past 7.5 years, Mr. Taws has designed, built, and tested various energy regain systems. These systems have been tested by engineers and scientists representing government and industry in Canada. Until now, a tremendous blanket of secrecy has covered this work. As we heard a moment ago, Mr. Taws, the present generation of your energy regain devices has been a fact of life now for 2.5 years. Can you recall for us an event or sequence of events which started you on this dynamic breakthrough?
Well, Mr. Willis, we were a design office catering to the automotive and aircraft trades, the aero engine as well as the airframe, some defense contracts. And this is a very fertile breeding ground. We're a very good type of man working in design engineering because he's trying to overcome problems daily, dealing with contours and forms that have never existed before, as in a new automobile, the tooling up thereof. But the work that actually triggered us off on this pursuit was a contract with Lucas and Arthur, the meat packing people. In the course of this work, an accident occurred where a carbon drill rod fell within the sphere of influence of this low-frequency cycle.
Accidentally?
Accidentally, absolutely. And it became immediately cherry red, which under ordinary circumstances any metallurgist would not expect it to or become influenced for at least 5 minutes in a furnace, for example. So many theories were propounded by the three of us who witnessed this event. We were astounded and dumbfounded, of course.
You didn't know how it happened?
Oh, not at all. No idea. It was quite startling. And we built a toroidal vessel, which is to say a stovepipe within a stovepipe within a larger stovepipe, say 4-inch diameter within an 8-inch diameter within a 12-inch. And these would be spaced with galvanized tubes and bits of angle. And we used drill rod as our flex density core. And we wound a helix round the outside and just blew air through.
The helix is a piece of...
An electrical conductor that you wind round in progressive fashion, not over itself.
No.
Just as you a fishing reel, for example, you know, as it winds in. But, well, we did not know what produced these startling results from this, but we were trying to find out what the influence of induction was on atmosphere, ordinary atmosphere, which contains moisture being blown through these. And we read the wet and dry bulb thermometer on the input side and compared it to the output side. And this appeared to be quite a considerable heat regain, which is to say more energy coming out than we actually put in. And,
how long would this tube be, Mr. Taws?
Oh, well, the first one we did, I think, was about 8 feet long. We eventually went to 29 feet long. Yes. We found that what happened was that the atmosphere, humidity is vapor clusters, and we, by bombarding with induction in the course, as it ran the gauntlet, as it were, from one end to the other, that's right, we were breaking this down into molecular form, and thus releasing some energy. For instance, you know that clouds contain electrical charges.
Yes.
So we were releasing some of this, you see. And
this is what turned the rod?
Partially. We were on the track. Yeah. We were on the track, as it were. So we called in, anyway, James Cowley, for instance, president of the Cowley Consulting Group, to confirm what we claimed to be an energy regain. And as he pointed out, and his report is representative, I would say, of all consultants of that period. Remember that we progress annually, and we accept today theories that we wouldn't even have dreamt of some time ago. But the Cowley report more or less stated that, assuming the instrumentation was correct, it would appear that there was heat regain. Dr. Mackay, for instance, of the University of Toronto, he didn't actually measure the machine. He came and discussed it with us. We had sent a fee to the Featherstone Howe, whom we were trying to get a patent from them at the time, and they had asked permission to hire him at our expense, of course. And he came down, but he didn't wish to measure the machine. He decided...
Now, when he would come to measure, he would measure the as you explained it, the input and the output.
And the output, yes, that's quite so. But in this case, he didn't particularly want to measure it. Later, via the patent attorneys, he sent word to the effect that, in his opinion, that we were misreading the instruments on the output side, and that our thermometers, although they were alcohol and glass, you know, were affected by radiation.
From where?
Well, assuming that there was radiation, and assuming also that he also suggested that vibration occurred to some of the tin inside. You require energy to vibrate something, of course. Yes. Ultimately, we called in Dr. Harold Blondell, the co-inventor of the cobalt bomb. And it was he who, we were still theorizing as to what had happened, and we called it cosmic effect. Just as an X-ray is brought to a dead halt by lead, for instance, a lead sheet. We thought that accidentally we had brought a series of waves or impulses to capture a cosmic effect. But he, after spending a day with us analyzing the systems, stated categorically that we could not expect reliable scientists and professional engineers to measure accurately enough. We thought, of course, that our margin of output was so much greater that there was no quibbling about accuracy of instruments. However, we agreed that we would convert everything into water. Everything is measured relative to water, all specific weights. Water is number one, specific weight 1. And if you heat it or cool it, it's at the rate of 1 degree Fahrenheit per pound per BTU, British thermal unit. A measurement of energy, yes. And you can convert water, electricity, or any other form of energy into BTUs. So this would be the most desirable way of measuring output over input.
Essentially, then, the initial discovery led to the development of a system which could be accurately tested by other scientists and engineers.
Yes, that's right. A theory is similar to a map. It tells you what you'll find if you travel a certain route. But we realized, of course, that we had discovered uncharted territory to which there was no map, and so we could only predicate where we were going and how to best get there. Our discovery was so monumental that there was no explanation for it in contemporary physics to account for this phenomenon, you see.
You must have realized, though, the potential of this breakthrough for Designex, particularly after your previous successes with solid-fuel propellants. How did the research develop?
Well, we were a substantial company. We had about 50 engineers, and we were able to make a fair margin of profit. And what profit we made it with the right hand and gave it out with the left, as it were, to the experimentation. But the high cost of this eventually, after 6 years, broke us financially. So actually what we did was to obtain further contracts and concentrate more on the payload sort of work. We had a very substantial contract of the Bell telephone, for example, which sustained us a little further. But we decided that we could not accept certain types of work because there may be a conflict of interest. An example of this would be we had done some work with Shell Oil Company, and they had inquired whether we were interested in doing some more. But by the time they asked us if we would embark upon yet another venture, we now knew that their method was obsolete.
At this stage, when you realized that their systems were beginning to be obsolete, was your machine that same machine of the tubes?
Oh, no.
Had you gone on?
No, we were graduating toward more sophisticated equipment. And we were discovering many side, shall we say, inventions, for want of a better word. We had to invent certain systems in order to overcome deficiencies or problems.
I see.
Oh, yes.
Now, at this point, your engineering design company had ceased operation. You'd sold your house to pay off debts that had accumulated while you were developing your discovery. And the general reaction to your experiments were not encouraging.
No.
Now, notwithstanding all of this, you pressed on.
Yes, well, at the laboratory, we had been using open systems, which are hard to measure. And despite the fact that we had converted into water measurements, as Dr. Blondel had suggested, thus removing any assumptions of instrument readings, accuracies. So we moved toward closed systems, and for this purpose we formed a company called Energetics in order to deal with these closed cycles. These are similar to refrigeration systems. You never see the gas emit or exhaust therefrom. It continues.
Did you have your finished machine producing usable electricity at this point?
No, far from it. We did not have a map for the territory we had entered, so we decided to use off-the-shelf equipment, as earlier noted, Dunham-Bush compressors and condensers and cooling coils, and the DuPont R22, Freon 22, as the refrigerant. The reason for this, of course, was these items have known efficiency ratings with which to compare what we could produce with. So this would allow us to have our efficiencies determined with far greater accuracy. We were on the road to making electricity. We had insinuated a turbine into the system and been rather pleased with the results because this increased further our cooling effect or refrigeration effect. It's an ideal condition for the commutator or the rotor to work in because moving as it does with the speed of the turbine, and the turbine goes rather faster under these conditions because of the Claude-Lindy effect. The gas, as it emits from the exhaust ports of an air tool, for example, collapses into a low temperature. And the lower the temperature you can generate electricity in, it's of a great advantage. Plus the added fact that any heat or energy generated by both the turbine and the generator is picked up in the gas passing by on its way to the cooling coils.
Now, I hate to be nosy about the machine.
All right.
But at this point, it's not the tubes anymore. It's number 2 or 3.
It's a fairly simple system comprising of a refrigeration compressor, a series of different diameter copper tubes, off-the-shelf hardware in general, such as coils, condenser, and cooling, as well as a cylinder is insinuated into the system near the discharge, gas discharge point, ready to house the turbine and the generator and even the transformer. In addition to this, there are several machined parts which at this moment shall remain secret.
Mr. Thomas, other than the compressor, which is part of your system, and the generator, which you introduce into the system to produce electricity, are there any other moving parts?
Well, it's a question here of qualifying which system, because this is rather a complex affair in that it lends itself in many directions. Basically, the basic system itself, as described a moment ago, is in and of itself admirably suited for simplicity of design. It has, as its key feature, rather fewer moving parts than any other system hitherto. The intention was to get away from over-sophistication. The key feature that we had then was to operate at a low temperature where there's very little wear. In other words, to try and get as near entropy zero as possible. Thus, the longevity of the machine is greatly multiplied.
And it is obviously quite a bit bigger than the tubing and so on.
Oh yes, yes, quite a bit bigger at this particular stage. We had at first tried to use car generators, but we soon ran into their planned obsolescence. Yeah. And then we switched into aircraft generators, which are lighter in weight, smaller, and of higher rotations per minute. And we found that we were getting far higher rotations per minute than the manufacturers claimed under these particular conditions.
Now, at this point in development of your system, you still needed electrical input to keep your prototype machine running, although you got more and more work done on less and less electrical input.
That's correct. It was during this period that one of our experimental machines hit upon the datum line, or what they call the state of equilibrium of gas. Now, this is not unusual. Every gas goes through a state of equilibrium, but only for a fraction of a second or a millisecond or something like this. No one really timed it. We were too excited, but it was between 20 and 30 minutes, say. And each one of us in turn jumped and felt it. And the nearest thing I can describe is, although I've never had a divining rod in my hand, is as if I was holding one. You sense it, you feel it. The gases are struggling with each other. The molecules want to go up or down. And of course, this is the datum line which enables us to think of the Carnot theory as something more than a theory. This has been a sort of dream of mankind, if you could have a cold heat engine.
Mm-hmm. Mm-hmm. Mr. Thomas, you've given us a highly detailed and technical history of your apparatus. But I get the feeling that what is most important here is that the system is infinitive. Now, does that mean your machine will be able to operate and generate electricity without drawing energy from an outside power source?
Ultimately, yes, we will be able to. If we put X units of energy into a system and obtain Y units out, and this represents twice as much as the manufacturer can claim for his system, by insinuating this turbine generating into the system, we increase the Y into a Y plus output. And bear in mind, we have in the meantime got some work done by the turbine, which is to manufacture some electricity. This therefore must be deducted from the input. Therefore, we now have less going in and more coming out. This is infinitive.
Yes, also creating electricity. Sure.
That is why we call it the infinitive concept.
In other words, once your system reaches a certain point, it becomes ultimately self-regenerating and will continue to operate independently without an outside power source to generate electricity while developing increasing refrigeration effect.
Ultimately, yes.
Now, sir, what independent confirmations did you have on these astonishing claims? It would seem to me that you should have been entitled to governmental support in this undertaking. What steps did you take in this regard?
Well, it's very difficult for these people, these consulting engineers and so on, to go against their teaching. They have been taught certain basic principles. They are taught how to deal with energy budgets. And if one is lacking in output relative to the input, in other words, if it's X in and X minus so much out, everybody's content and happy. But they've never come across a case where the reverse occurs. Now, they also don't want to disrupt their lives. Remember that most of these PhDs and so on are on 2, 3, 5-year contracts. And as witness what's happened here in Ontario right now, for the next decade we are going to pursue research and development of atomic energy. Therefore there is very little money, if any, left for any other work. And we conducted thousands of experiments, and we called in such as Mr. Puccini of the Aerospace Division of the University, the Ontario Hydro and so on. These people had tested earlier systems. Then of course we called in professional engineers such as Ernest Langenham and Eric Creaser, and the Ontario Research Foundation. Mr. Campbell came up from there, and after an explanation of how the system worked, the system that he saw was an aim at purification of water. And within the hour, he saw the total entrainment of kinetic energy, the art of application as against a scientific breakthrough per se. This is merely gathering the energy that's always existed. He was very favorable, and witnesses can attest to the fact that he was ready to recommend financial support of some substance. And later, Mr. Holland, the director, came up to verify the amount and to satisfy himself that this would be sufficient to carry on the work.
The amount of the grant?
That's right. Well, it was about 100,000 at the time. I would have considered this quite satisfactory at that time, because we were only aiming at one aspect of the work. The grant would have been toward that particular aspect. Later on, they sent a Mr. Doman and a Mr. Christie up. They did not measure the machine. They merely discussed matters with him. They read the Langenham report, which was by now available, and they decided not to measure the machine.
But did they look at it, or...?
Yes, they were very searching in their inquiry as to where the extra energy came from. And the best analogy I could give at the time was a box full of bullets. Employed in an equal caliber handgun and rifle. Now, you assume that you have this box full of bullets in your pocket.
Right.
Now, the amount of powder or energy, or fuel if you like, explosive fuel in this case, in each bullet is more or less the same. Now, if you put a bullet at random into a handgun, fire it, it goes about 60 yards.
Right.
If you put one in a rifle, it goes much further.
600 yards?
600 yards or so, yes. And if you empty the box thus, you'll find that more or less, plus or minus 5%, they'll react accordingly. This, I think, is a very good example of the art of application. So when we talk about a breakthrough, it's the art of application.
I see.
We're not saying that we've discovered a new energy somewhere. We're just able to corral it, shall we say, and employ it. Now, we were daunting a little along this time, and I phoned up Mr. Otto Lang, the Minister of Energy and Resources, as he then was, and he met with myself and some colleagues at Malton Airport.
Mm-hmm.
He was sufficiently impressed by our sincerity to send Mr. Ted Rattray and another colleague from the National Research Council down to measure our machine. And Mr. Rattray felt that it was a breakthrough in the state of the art, which is to say, it is a bit of a breakthrough.
Yeah.
And he told some neighbors this and people that were nearby at the time. I remember well, a visitor came up my drive and he even collared him and said that it was quite a breakthrough. But when he came a second time, usually these people ask for modifications. Well, it operates this way. If you change this, will it operate equally well? And of course, there's no thought in their minds as to the cost involved in these changes. But in order to prove the veracity of the machine.
Well, don't you think they're so amazed by it that they want to change back to something they can understand?
Well, of course, everybody who sees a breakthrough or an advance in the state of art wishes to relate it to some law.
Yeah, of course.
Indeed. And when there is none, you see, it's rather difficult. You're out in left field somewhat.
Yeah.
Well, I remember he jocularly, this gentleman jocularly on the second visit said to his colleague, you better phone in these results, meaning to Ottawa, because they'll think I'm drunk again. So, but the attitude of later arrivals from the National Research Council, one gentleman unofficially felt that we were 6 years ahead of others, but the official visitors preferred to think that we didn't have a breakthrough after all, and indeed they stated in writing later that categorically no one could ever produce electricity thermodynamically.
It's hard to believe that professional engineers representing various government agencies would test your prototype, agree with your results, and then never be heard from again. Do you feel that the results were repressed at some level?
Oh, we know fairly well that at one level in the Ontario Research Foundation they were, because Mr. Campbell's report, it was said, never arrived at a high level. But that is quite true, apart from the economic implications of our discovery. People are just bloody scared of it, that's all.
Well, now that you had outside confirmation in support of your claims in writing from Langen and Puccini, you must have been welcomed by practical-minded businessmen who might have helped you.
For the greater part, they were still reserved, but I did foresee the necessity to at least keep them informed, notably the late Senator McCutcheon and the Senator Rupert Davis. I asked their advice as time went on, and as we progressed from one experiment, one plateau to the next, yes, I did keep some of them informed. And my lawyer, Douglas Morton, now Judge Morton, he helped me in this regard as well by sending some consulting engineers from Dilworth and Secord, a notable consulting company, to measure, if you like, our machine and to report upon it to a would-be investor. Upon arrival, they just asked a colleague what they were to be going to test. They said we had heard we were going to be dealing, among other things, with a reversible cycle. When my colleague answered them yes, most certainly, they just jumped in the car and went the other way. We never heard any more.
They didn't even measure the machine?
Well, one of them did say that he had been through university and had learnt that it was impossible to do so, so that was the end of it.
Why would they have this kind of an attitude? Why didn't the businessmen come in droves, as I would think they would?
I don't know, it's rather difficult to answer that question. I can't answer for them. Of course, I'm disappointed that they take this attitude, and they have done so throughout history. They're only following a pattern.
It's a fear of disruption?
Well, I'll tell you, my own company lawyer, Douglas Morton, at the time, suggested that we had arrived at a point of what they later called politically with President Johnson a credibility gap, you know.
Yeah.
So he asked me one day if he could enlist the aid of a personal consultant, and he would pay him privately. And he got a very senior man indeed, one David Campbell, probably the top engineer in Canada at the time, to advise him. So he brought David Campbell down, and he just felt the machine, saw the compressor, closed his eyes, beckoned Doug to come with him, and later on I heard that he was quite impressed, sufficiently so to advise Judge Morton to tell me to get in touch with Ilka Jones of the Consumers Gas.
Mm-hmm.
Because all the time you run into people such as David Campbell who are under solid contract to oil companies and vast interests, and they're not free to act on your behalf, you see.
Mm-hmm.
So information appears to have been suppressed in industry to some extent, because Ilka Jones's first reaction as the head of Consumers Gas would be to send down his key man. His key man was not available. They seldom are on such occasions.
Yeah.
So the second in command comes down, and we did make a proposal in writing to them.
Mm-hmm.
Mr. Ralph Long of Dunham Bush came down. We asked him to arrive and measure, and when he saw that we seriously and sincerely had something in the nature of a major breakthrough,
Yeah.
He abandoned further tests and advised us. We had called him down as the top Canadian company, as we thought, and he advised us that his company had then been purchased or taken over by an American concern. But he was quite firm that we had a breakthrough with his, and were able to do something with his equipment that his own company were unable to do.
My name is Ralph Long. I am a vice president of Dunham Bush of Canada, a company who for a period in excess of 40 years have been manufacturing industrial heating, refrigeration, and air conditioning equipment. I personally have been with the company some 30 years in production, sales, and system application, particularly in refrigeration application. During the early part of 1970, Mr. Thomas purchased from our company heat exchange coils and a compressor, describing briefly the system to which the equipment was to be applied. Periodically during the following weeks, Mr. Thomas and his associates at the time reported several results. Being critical of their claims, I was invited to personally conduct a test of their system, which I did in July of 1970 using my instruments. I was again invited to see the system in 1971 and noted several modifications had been made in the equipment, which had been in operation for several hours before my arrival. I noted one component of the closed system heavily frosted, and also noted the suction pressure was at 70 pounds pressure, or a corresponding temperature of 37.9 degree Fahrenheit. And as ice forms at 32 degree Fahrenheit, this condition was impossible. The temperature at the frosted component, incidentally, was minus 40 degree Fahrenheit. The foregoing, plus my lifelong experience in this industry, proves existing refrigeration systems are obsolete.
If I may, let me try to put this into perspective, Mr. Thomas.
Yes.
A professional engineer has reported that the performance of your energy regain system is contradictory to the second law of thermodynamics, right? Now, a senior engineer in charge of North American pipelining for a major oil company once called your system perpetual motion plus. And the vice president of the largest manufacturer of compressors in North America states uncategorically that your system makes every piece of refrigeration equipment now in use obsolete. Well, to me, the question that remains is this: why has there not been a tremendous uproar in the scientific community?
We must keep in mind here that we are not dealing merely with a new invention. Our discovery represents a new view of the universe and our place in it. A scientific theory basically is a set of premises which seeks to explain a certain set of data. Now, if the data is brought to light or found or discovered which contradicts that theory, we change the theory, not the data. Unfortunately for us, the second law has provided such a far-reaching base of technological development over the years that data contrary to it is actually legislated against. You see, before 1913, the pre-general theory of relativity, the Newtonian view of the universe was entropic. The sun is running down in its energy, the world is running down in its energy. And then along came Planck, Kupriyanov, Niels Bohr, Einstein, and Minkowski. And these people gave it a finite view, that nothing was lost. Even voices are transformed. The energy from my voice at the moment is not lost. And all of this was encapsulated by, ultimately, by Einstein bringing out that well-known E is equal to mc squared in vacuum. Energy is equal to mass times the speed of light times the speed of light in vacuum. And remember that there were other people, such as Heisenberg, who has written extensively about the laws of uncertainty. In other words, that you don't have to circumvent them. They, in and of themselves, are not absolutely on sure premises, you see. So we are now entering the infinitive period. Pre-1913 was entropic, or running down theory. Post-1913, encapsulated by Einstein in E is equal to mc squared in vacuum. This is the finite period. Now, we are merely proposing that there could be an infinitive period. If the laws can't embrace new data, they should be changed. As Einsteinian theories replaced the far less realistic Newtonian laws, perhaps now is the time for another change. And in light of our discoveries, we believe so. Now, man is always careful and chary of comparing himself to God. The patent laws were formulated originally by very Christian people in England, Germany, and so on, and they've been adopted elsewhere. And indeed, even the communistic countries have adopted them. They believed, you see, sincerely that God alone is infinite, God in his infinite wisdom, God in his infinite power, and so on. There is no reason whatsoever why science and religion can't get together. The laws, civil as well as patent, must change to encompass or embrace the new realities. I remember about a couple of years ago, my lawyer, he is now Judge Morton, he was then Douglas Morton, QC, he went to Ottawa to verify the fact that you could not patent anything that had an input, say, of 100 with an expectation of an output of 100 or even 99.
Because no man could be 100%.
Quite so. And this, of course, would have supported 19th century science, the Newtonian view that everything was less and running down. And, of course, they banish any advice. They throw you out as a complete idiot the minute that you arrive there to apply. All this now must be changed, this attitude toward things, because most existing mechanical engines or systems now becomes obsolete. Anything that's been driven by, say, combustive power, whether it's steam or internal combustion of gasoline and so on. We've come through a combustive age.
Well, it's not necessary anymore, then, if we have a different way of getting energy.
Well, when we pause and consider, you know, everything that we've done thus far is at odds with nature. We thrust against it. Yes. The rocket thrusts away from the gravity of the Earth and so on. And I think it's time that we became one with nature, attracted more to it. Employ it as it is. It's a sort of trans-industrial breakthrough. All fossil fuels, for instance, coal, gas, oil, and so on, as well as uranium, will be made obsolete in the not-too-distant future as a result of this. Therefore, all industry that now employs their energy source therefrom must participate in the development of this new device.
Now, in other words, in answer to my question, the decrees of the government should then perhaps be changed.
Well, if our free societies, as we call them in the Western world, are to survive this inception of freely available energy, it is well that we would control the phasing in while the old is being phased out.
Could you outline for us a few of the tremendous benefits which your energetics breakthrough holds for the future?
The answer to the question of replacing the aircraft jet turbine engine is energetics systems. Aircraft in their present form will disappear into museums or extinction. Runways will be unnecessary. The sonic boom of today will disappear with today's generation of aircraft. The total force of propulsion will be internal, and the atmosphere in front of the vehicle will be collapsing into silent travel. Just as the discovery of potentially enormous flows of electrical energy has preceded subsequent inventions based on its use, space travel will become an economic, practical proposition once our newly developed energy regain devices have been integrated into accommodation systems. This technical revolution will certainly require new international legislation. Like the airplane, automobiles, indeed all internal combustion vehicles as we know them, will cease to exist. In the beginning, today's motorized vehicles will be replaced by a generation of devices similar in exterior body design and function for on-ground use. These vehicles will operate electrically by means of a built-in energy regain device. Brakes will be electromagnetic and will therefore be friction-free and fade-proof. By assigning all vehicles a relatively identical polarized magnetic field or charge, they will become collision-proofed as well. The built-in energy regain device may remain active through the life of the unit. No more on-off, only stop-go. In a short time, the new transportation industry will make available a second generation of related devices, offering a wider range of functions. These vehicles may hover from the moment they are activated until they are dismantled for recycling. Once energy became freely available, all current concepts of the division of labor and mass production become obsolete. The new production facilities may deliver any electrical appliance one can name with a power source built in. The lifespan of these new machines will be planned by a vast computer system employed in designing future model designs. This new appliance technology will require minimum maintenance, cost relatively little, and will not wear out. As the end of their life cycle approaches, appliances will be recalled for recycling, and a new, improved generation of appliances will be substituted into the consumer equation. This tangle oozing coronal losses should be viewed as a relic of the past. Installations like this one will be needed until the changeover to decentralization is completed in some years' time. In the future, man will use energetics systems to develop the required electrical energy at the location site. Hospitals, factories, apartment complexes, individual homes, and auto transports will contain individual or community energy regain devices developing electrical energy to serve the increasing needs of mankind. Once again, we are looking at the nuclear station located on the shore of Lake Ontario. This installation was constructed at a stated cost of approximately $750 million. Add to that figure the cost of the land and the interest on the money borrowed, plus the shared expense of developmental costs with a donor nation, plus all the non-disclosed costs classified as secret or top secret, and a newer, more complete cost picture emerges. In the past, centralized authorities controlled the centralized distribution of energy in the form of electricity and fossil fuels. Now, with the newer energy regain devices, all that is changed, and the development of electrical energy will become increasingly decentralized. The impact of this beneficial development upon mankind cannot be predicted fully.
In the Sources of Invention, the authors state that nearly all the important inventions in steel in the 19th century came from rank outsiders whose ignorance of what could not be done was their chief asset. Farnsworth, the inventor of television, tells the story of how at one stage a professor gave him reasons why his ideas, subsequently successful, could not possibly work. Shortly before, the jump forward in solid-state physics, represented by the discovery of the transistor, scientific authority was being claimed for the belief that nothing more was to be known or found in this field. The list of instances where a fresh and untutored mind has succeeded where the experts have failed or have not thought it worthwhile trying could be greatly extended. Gillette, the inventor of the safety razor, was a traveling salesman in Corks. The joint inventors of Kodachrome film were musicians. Eastman, when he revolutionized photography, was a bookkeeper. Progress is achieved when man increases his understanding of nature to better the quality of his life. There is no apparent end to the secrets which nature withholds. The inventions I have cited merely serve to illustrate that major discoveries are not necessarily made by the specialist in the field concerned. Mr. Thomas views himself as a novice in the field of thermodynamics. History, I am sure, will disagree.
You flatter me, Austin, and I do indeed feel humble in the presence of what I have seen and sensed and measured and felt. However, in this instance, there is no single invention, but rather a major breakthrough, from which will flow a whole generation of inventions, each of which will affect the life of every viewer, and for that matter, every non-viewer as well. This breakthrough ultimately obsoletes all current sources of energy and all appliances now in use. Pollution is surely a thing of the past. Space travel becomes a practical reality. With free energy, man becomes the master of his own destiny. It is now incumbent upon all of us, and I fully realize myself in particular, to see that the results of this breakthrough be made available to free men everywhere, in such a way as to not completely dislocate our economies. In this regard, I will need all the help I can muster. I am determined to work with all men of goodwill for the betterment of all. And I invite the major manufacturing institutions to join with us in establishing appropriate research and development programs, to join with us in making available to the public an early generation of consumer products based on our breakthrough, and to continue in association with us to the point where all men may have available to them this new bounty of science. I say to you, the people of this audience, I am extending the prospect of the infinitive concept to you, to your children, and your children's children. Let no group, however constituted, withhold it from your grasp.